Right now, the world is desperate for copper to fuel the EV and AI revolution. Copper is the nervous system of the modern world. Without it, the AI revolution has no brain and the green energy transition has no pulse. But behind the scenes, the multi-billion dollar giants built to produce it are drifting into technical and physical insolvency. The smelting industry has hit a copper crunch, a perfect storm of 35% cost overrun and dirty concentrate. Today we are breaking down why the world's newest smelters are failing before they even finish their first year of operation. CAPEX failures are primarily driven by an average 30 to 35% project cost overrun due to inflationary pressures on specialized alloy steels and EPCM, that is, engineering, procurement, and construction management labor. As of January 2026, the global smelting baseline is defined by a concentrate crunch punctuated by the Q1 2026 commissioning delay of several 500 KTPA plus facilities due to structural inability to secure feedstocks with less than 0.5% arsenic content. Smelters remain idle due to 20 to 30% reduction in upstream concentrate supply. Quantitative analysis indicates that 2026 IRR for greenfield projects are under threat as initial ramp up achieve less than 15% capacity utilization due to global ore shortages. Critical edge case failure unique to this phase is the geotechnical instability of block cave feed sources where unforeseen seismic events in deep level mines cause immediate feedstock strangulation for downstream smelters. Operational success in 2026 is defined by a byproduct offset ratio where sulfuric acid and precious metal recovery must exceed 40 to 55% total operating cost to suppress the negative TC error factor. The industry average ROI for greenfield smelters has declined. High fidelity success is measured by achieving a direct to blister copper recovery rate of 98.5% within the first 12 months of commissioning, a metric currently missed by 60% of new projects. Project viability is now benchmarked against a 95% hot commissioning uptime within the first 180 days, a metric currently missed by projects that underestimated the scale up latency of automated matte typing systems. Leading smelters are targeting a 99.2% copper in concentrate recovery factor, leaving traditional facilities with 1.5% losses at a distinct competitive disadvantage in a high price LME environment. But here is the $1 billion blind spot. You can have the best metallurgist and the deepest pocket, but in 2026, the industry is running into edge case failures that weren't even on the radar 3 years ago. We are seeing a lethal trifecta of chemical, environmental, and digital vulnerabilities that are turning these icons of industry into fiscal black holes. A primary 2026 failure mode is refractory thermal fatigue, where the aggressive chemical profiles of custom concentrate corrode furnace linings 40% faster than predicted in 2023 era feasibility studies. Concentrate impurity saturation, where high arsenic and antimony levels in new feedstocks exceeds the design capacity of gas cleaning systems, triggering immediate environmental shutdowns. Sophisticated cyber physical vulnerabilities have emerged in the SCADA systems of smart smelters, where an edge case breach can desynchronize oxygen to concentrate ratios, leading to catastrophic furnace freezing of uncontrolled explosions. Roadmap S2 2026, immediate technical requirement to focus on multi-feed flexibility retrofits, allowing smelters to pivot between primary concentrates and high-grade copper scrap secondary smelting to survive the concentrate shortage. 2027 scalability projection. By 2027, the industry will pivot towards hydro hybrid pyro circuits, allowing miners to bypass volatile custom smelting markets by integrating on-site leaching with small-scale, high-purity cathode production. Advanced integration. To meet tightening 2026 ESG mandates, stacks are now tethered to AI-driven gas cleaning systems that utilize real-time sensor to modulate sulfur capture based on fluctuating concentrate chemistry. The failures of recent CAPEX projects stem from a design feed mismatch. While Indian smelters has attempted to mitigate this through massive scale and JLD, zero liquid discharge integration, seawater desalination to mitigate regional water scarcity risks. The broader industry is struggling with the transition from high grade primary ores to complex impurity heavy feedstocks. So, who survives the copper crunch? The winners aren't just producing metal anymore, they are operating as complex chemical refineries capable of extracting value from the entire periodic table. By S2 2026, the industry is pivoting to multi-feed retrofits and AI-driven gas cleaning systems to meet brutal ESG mandates. The era of simple smelting is over. If you want to understand how the 2027 pivot to hybrid Pyro-Hydro circuits will change the game, make sure you are subscribed. We have linked our deep dive report on the design feed mismatch in the description. Click here to watch our next video on why Indian smelters are leading the charge in zero liquid discharge tech. I will see you in the next one.